Hey everyone, I hope that you're enjoying the playlist, and if you are, please give the video a like and share it. It really motivates me to create more content like this. And also, don't forget to drop a comment with your thoughts. I would love to hear what you think. So today we are starting a new module in the complete Agentic AI course. Today we'll see like why do we need rack system. So from the playlist we are starting this module. I'm calling this as a knowledge assistant, and you can start with the first notebook from here. So before we talk about rack system, let's understand why you really needed rack system at the first place. We have seen this before that we can call a LLM chat model. I'm calling the GPT OSS model right now, and I'm using LangGraph to call it. But I'm asking a very specific question that what is the return policy for Anirban Decode's e-commerce products? So if I ask this, you see the response for this that it will say that I'm not able to locate a specific uneven decodes return policy in my current data because this is a model that was trained by OpenAI, and they do not know what is uneven decodes e-commerce product, right? So it does not have that information. This is where you'll need a RAG system. Why you need a RAG system? So RAG is called as Retrieval Augmented Generations. So first thing first is LLMs don't know everything, right? So whenever some company like OpenAI or Anthropic or Microsoft or any big companies, whenever they train any model, they use all their data to train it. But they do not know all your business data, right? Suppose you are a company, they do not know about your company, or there are some data that is not accessible in open internet. Any big companies cannot train their model with your own business data. So they cannot magically know your company policy, recent data, private documents. But you cannot give your private data to OpenAI to train their model, right? This is when you need RAG system. I'll talk about that. How do you create the data? How do you feed the data to LLM model and all that? LLMs can hallucinate. So if you see on the top, it will start talking about few things that they know, right? It will say that okay, visit the retailer's website, check the product page. Even if you do not have a product page, it will start making some content, right? So this is a very common issue with LLM models, that it try to hallucinate, right? It will try to give you some response even if it doesn't know that. Knowledge changes, right? So think about whenever your product whenever your project or your company is doing any changes, so everything changes, right? That laws, prices, product space, they are all changes, right? So you don't want to retrain or fine tune a giant model every time something updates, right? So you do not want to retrain your OpenAI model to whenever something changes. So this is why you need a rack system. And you also need a domain specific answers, because OpenAI might not know your business domain, right? So you want to give the information of your domain knowledge to the model so that it can generate answers. And the last thing is cheaper and faster than fine tuning. So fine tuning is basically you get a LLM model, like suppose OpenAI model, you fine tune it with your own business data. But this is very expensive process, and not all the organization can do or do not want to spend a lot of money to do that, right? So this is why they use rack system. Think about like you are searching for a document, right? Like you stored the document in a relational database and you can search the document through it. But what's the problem with plain keyword search, right? So computers match exact word, not meaning, right? So think about like you are querying a database, like select start from the table where column name equal to something. So you basically doing a exact match. You are not matching those words in the meaning way, right? Let's see an example. Like suppose you're typing a questions like laptop battery problems. So keyword search may miss a document says notebook isn't charging. So if you see, there's a relation between these two sentences, right? Laptop battery problem and notebook isn't charging. But if you do a plain keyword search, these two sentences won't match, right? And you'll miss this two document together altogether. But these are two different words, but the same idea, that there is a problem with the battery, because of that notebook is not charging. So this is where your embeddings come into picture. So in plain words, an embedding turns text into a list of numbers. We call it as a vector that captures meaning. So the idea is very simple. Items with similar meaning, that vectors are close together, or items with different meaning, that means vectors are far apart, right? Think of it as giant map, right? So laptop and notebook are neighbors, but banana is far away from both, right? So banana is not related to laptop and notebook. So the vector distance between these two words will be far. So that's why you will understand, okay, these two words or these two sentences are not related. So this is how the embedding work and also the search works. So I'll not go to very mathematic way of representing it, but let me tell you a very simple way of how the embeddings, how the dimension works. So think of, you remember we talked about that we can categorize a sentence into different dimensions. For our example, let's just say that we are categorizing the sentences into three different say dimension. That is, first dimension is topic, second is tone, third is sentiment, right? So let's think about topic, that we are talking about cooking or anything related to cooking. That's our topic. And tone is positive, negative. Similar, sentiment is positive, negative. So how to bake a cake? So this is related to cooking, so the topic is very related, so we are giving this 0.9. Tone is neutral, and sentiment is also like positive, and cooking is fun, so this is also related to cooking, so we are giving this as 0.8. Similarly, tone, similar, sentiment. But if you see that, I have a sentence called as AI models are powerful, so this is not related to anywhere cooking, right? So we are not giving this very closer, right? So you're giving this as 0.2, and the tone is very positive, and the sentiments is also there, right? So this is how you represent any sentences into three different dimensions. But in real world, there you'll see that the models that we're using, those uses like 30 billion dimensions, right? So think about all every other dimension that you can represent this sentences, or maybe you can categorize a sentence like, is it a food item? So you can have a dimension like, is it food? Then depending on that, you can give it as like 0.8 or that. This is for just for example, for you to show that how do you represent a sentence into different dimension. So once you're able to do that, this is how you calculate the distance between these two, right? So we call this as a Euclidean distance. So you have two vectors, that is A and B. It could have multiple dimensions, right? And you can create a distance between these two like with this particular formula. So let's take an example that I have a vector, that is vector 1, vector 2, which is related to how to bake a cake versus cooking is fun. And the Euclidean distance between these two vectors is 0.173. This is very small. That means this is very similar sentences. Let's take an example of how to bake a cake versus AI models are powerful. So the Euclidean distance is 0.943. This is far. That means not similar, right? So this is the whole idea. So you divide your sentence into different dimensions like this. Then you create Euclidean distance. If your Euclidean distance is smaller, that means these sentences are similar. If far, then not similar. So the short explanation is, if this is are close in topic, then it's a match. If these are not close, that means this does not match, right? Once you understand how the embeddings work, then we see that how embedding based search works, right? So there are different steps. So first step is like you split your documents into small chunks, that is paragraphs or like sentences or words. So why we do that? Just think about, like, if you're feeding the whole data, like if you're feeding like a book to your LLM model, so it cannot understand this properly. So you basically divide this in a meaningful chunks, and you then feed it to the LLM model. Then you embed the chunks. So we just talked about that, how to embed your chunks into different dimensions. So we basically use a embedding model to embed these chunks that we have created. Then we handle the user query, basically convert the user query into vector, because we need to compare the vector of a user query to the vector existing, right? So whatever the chunks is there, we need to compare those two, right? Then we find the similar chunks, then return the rank results. You could find it different similar chunks, right? Then we can ask the similarity search that, okay, give me just top k elements, right? Basically, if I want just a top 3 similar chunks, I can just ask the similarity search to give me top 3. So this is how the search works in embedding. Then how to build a rack system in simple terms. So this is just about the theory. We'll see this in details where I talk in the video. So first we collect and prepare your knowledge. So whatever the unstructured data or structured data that you have, it could have PDF, web pages, database rows. You break big documents into small chunks, meaningful chunks, like splitting a book into paragraphs. Index the knowledge so it is searchable. So we'll see like how do you use a vector database in Databricks to store this knowledge, and then we connect this retrieval to generation. You will see like how do we create a vector search tool which is connected to a vector database. So vector database nothing but which stores all these vectors, right? Similar like how we have the SQL databases, similarly we have the vector database which stores the vectors. So basically we first search the vector database for most relevant chunks, then feed these chunks plus the question into LLM like GPT, and the LLM reads and context and gives a grounded answer based on the actual data. So basically the idea is, if I talk about like on a high level, so we collect and prepare your knowledge, right? It could be like PDFs or CSV files or whatever it is, and we store this as a embedding. Now a LLM model will search the embedding and it will find the relevant documents on, and on top of it, it will give you the answer. So this is all the theory that I have for this video. In the next video, we'll see like how do we create the embeddings, and we'll also see like how do we create a rack system in Databricks. Thank you so much.